In this short video, I'm going to describe the Translocation protocol, and this is going to be the area above threshold version of this protocol. So I'm starting from the count size panel, and I'm selecting the Protocols button and choosing the option to browse protocols. Here you can see on the left all the different collections that are available. The collection I'm interested in is the Cell Biology Advanced collection, and there's the protocol I want, the Translocation, that measures the area above the threshold. If I click on the Load button, this protocol loads in the panel on the left. The dataset that I'm going to use the Translocation protocol is from the broad Bioimage Benchmark collection, and it has the accession number BBBC013. It's available to download. It's a very nice dataset. The protein of interest, called forkhead, which in this case is conjugated to GFP, is normally translocated actively from the nucleus to the cytoplasm. Now in this dataset, the experimenters have used two agonists which inhibit this translocation, so we expect to see the distribution go from a cytoplasmic distribution to become more nuclear. So you can see the agonists are applied in doubling concentrations in each well from 3 to 11 on the plate. There are also some wells that are dedicated to negative controls and positive controls. Here's my imported dataset, and these are the composite controls, showing two channels, one for GFP and one for DAPI. This is the plate viewer that I can use to navigate around this dataset. First step is setup, and it's important at this point that I have setup mode selected. Here we see a little warning saying that the protocol doesn't see the correct channels. Nothing to worry about, just means I have to hit the sync button, and then the channels in my dataset will become synchronized with the protocol. So after doing this, you see the channels update. Now I need to select the appropriate channels to detect nuclei and cells. Now I'm using DAPI to detect both nuclei and cells. If you have a whole cell stain, you could use that to detect cells. I've also set the channel for my translocation target, which is GFP. Having correctly configured the channels, I'm ready to move on and hit next step. And the next step is where we find nuclei. Now, this starts off by default with a threshold segmentation, and actually that threshold segmentation looks reasonable. It's found my nuclei very well, but I think I'll get slightly better results by changing to smart segmentation. So I'm going to select that option, and then I do my smart segmentation as usual. First, I select a couple of representative objects, and then I change to the background class and select an area of background. And hopefully Image-Pro will do the rest and find all of my nuclei, which is done really nicely. I'm happy with that. So now I can add a filter for area. So I want to add a minimum size filter. That's going to exclude all small objects, bits of debris, bits of noise, things that I don't want to include in my protocol. And I can also add a split option. I'm going to use the boundary shape option. Notice that when I change options that affect the count, the apply button becomes activated, and I can hit it to test my changes. I'm happy with that, so I can hit next step. The next step, step 3, is where we find our cells. And we're going to find our cells by finding our nuclei and then assuming that our cellular area surrounds each nucleus. And we start with smart segmentation, so as before, I'm going to select a couple of representative objects and an area of background. And hopefully Image-Pro will find our cells. It's done a reasonable job. I think there's perhaps a bit too much background being selected here, so we'll add an extra background region, and yeah, that resolves the issue. Now we've found our cells perfectly. Now I'm going to add a grow option. So we're going to find our cellular area by growing the region around each nucleus. So here I'm setting this to 50, and I'm adding a ring option, which means the nucleus will be extracted from the area that we grow. So we'll just let Image-Pro do the processing, and there we go. That's the region we're going to use as our cellular area, the area outside each nucleus. That looks perfect. I'm happy with that. So with that step complete, I can move on. I can hit next step. So in step 4, this is where we find the translocation target. So this is where we're going to look for the GFP stain. And here you can see this by default is using a simple threshold segmentation, to which I'm making a small adjustment, and that looks fine. Looks like I'm finding all of the area of GFP. I could set a minimum area if I wish, but I don't think it's necessary. I'll just hit next step. So the next step is the results step. This is where we configure the way we can display the results which are in the data collector. And we have several options. So if we click on Auto Show Results, we can choose from this list of different displays of data collector output types. And I really like the heat map, so I'm going to use the heat map and I think the block display as well, which I find quite useful. So here's my heat map, and I now need to configure how the heat map will be displayed. So let's choose which value we're going to display in the heat map. So I'm going to show the difference. So that's the difference between the nucleus and the cytoplasm, summarized by mean. And when I've set my results, I need to click the read button so that the results I set get associated with the protocol. I'm also saving the protocol here. Always a good idea to save your protocol so you can reapply it later. And that brings me to the end. So the protocol is now configured and ready to be run on the whole plate. So what I need to do now is deselect the setup mode and click Run Selected. It will then be run on the active range, which in my case covers the entire plate. So after hitting Run Selected, all of the welds are now going to be processed. You can see there's a little message there telling me that the document is now being processed in 6 threads. That's because I have 6 processors on my computer. It's a multi-threaded process, so that really helps to get through a large data set very quickly. You can see there's a progress bar in the protocols panel that tells me how far I've got through the whole data set. I'm also showing the task manager here, which gives a little bit more information about how the process is proceeding. I've speeded this bit up 20 times, but it still happens pretty quickly. It actually takes in total 10 minutes to process this entire plate, which I think is pretty impressive. So here you see when the progress bar reaches 100%, the results are automatically generated and the heat map is displayed and populated. Data collector is fully populated with 1 entry per image that we've analyzed, and you can also see the block display on the right. Let's return to the plate map and compare it to the heat map that we've generated using our protocol in Image-Pro. First, if we look at the regions of positive controls, here on the heat map, we're seeing a large difference between the intensity of the nucleus and the cytoplasm. Just a reminder, this heat map is showing the difference between the nucleus and the cytoplasm. If we look at the negative controls, here we're seeing a low difference. Effectively, the nucleus in these areas is darker than the cytoplasm. And if we look at the whole plate, on all of these rows A to H, we're showing agonist increase between columns 3 and 12. And this is reflected in our heat map by an increasing difference between the nucleus and the cytoplasm, between columns 3 and 12. So it's a really nice confirmation that we're seeing exactly what we expect to see using our protocol. So that brings me to the end of the video. Thank you very much for joining me. I hope you found the video informative. If you have any questions, contact Media Cybernetics and we will be happy to help.